Well, now we're going to look into transforms of a derivative, because if we're going to solve a differential equation with transform, we're going to have to be able to find transforms of a derivative. And look, we're going to do this for all orders of derivatives, which is incredible. Actually, if we do it for the nth order, we've gotten them all, because all the other ones would apply. So, if they're all continuous on the interval from 0 to infinity, are of exponential order, remember that means there is a Laplace transform, and if the nth derivative at t is piecewise continuous on 0 to infinity, that's not too much of a condition, then the Laplace transform of the derivative of t is s to the n times fs, where, of course, fs is the transform of f of t. And times s to the n minus 1 times f of 0 minus s to the n minus 2 times f prime at 0, etc., all the way down to the n minus first derivative evaluated at 0, and that one won't have a power of s attached. We'll start with the highest power of s, work our way down to s to the 0 in this term. But for our first example, we're just going to have a first derivative, so that would be a rather simple one. So here's our first problem we're solving this way. And this, look what this is. This is a linear first order. We could have solved this one with integrating factor e to the integral of 3 dt, so e to the 3t is the integrating factor, and that would have worked. But that's not how we're going to do it. And we also have an initial condition, y of 0, 6. So we're going to find the Laplace transform of this equation, the entire equation. Well, the Laplace transform of y dt is s times our transform function minus 6, that's, like s to the 0 times, which is 1, times f of 0, which is given as 6, well, y of 0 in this case. Maybe I should have used y for these, but I didn't. And then plus 3 times the transform of y, which I'm calling f of s, and that equals 13 times the transform of sine of 2t. Well, that's 13 times 2 over s squared minus 4. You can get that from a table. And so now what we need to do is solve that for f of s. So on this side, we got f of s factoring out and s plus 3 being the factor times f of s. Add the 6 to both sides and multiply this out and make 26 over s squared plus 4. So here's the 26 over s squared plus 4 plus our 6, and this side is f of s times quantity s plus 3. Common denominator in adding these two up, you get 6s squared plus 50 over s squared plus 4. So f of s is 6s plus 50 over s plus 3, this factor divided, times s squared plus 4. And so now we need a partial fraction decomposition. And you may recall, I hope you recall, that to do one like this, we need to multiply by our common denominator, which is this times this. And that gets rid of all the denominators over here. By the way, there's no heavy side for the s squared plus 4, so I'm just not bothering with it at all in this case. But so anyway, that means that 6s squared plus 50 is a times this s squared plus 4 plus b. Oh, why? Okay, I see why. I wonder why that got so goofy there, but I see that I'm on a line, so to speak, so bear with me. I'll try to move that off the line so you can read that better. Maybe I'll just hit one little enter. Nope, one little enter there. That's better. And then we're going to get bs plus c times s plus 3. And so from that, we can discern that a plus b, those are going to be the squared terms, that's got to be equal to 6. And what are we going to do for an s term? Do we have an s term at all? C plus 3b, both multiplying s. There's no s term from this, so c plus 3b has to be 0. And the constant terms, we got 4a plus 3c, and that has to be 50. So if we set up this, by the way, there's lots of ways to solve this, but I'm just going to use row reduced echelon form, and I did that, and a is 8, and b is -2, and c is 6. If you struggle with this, okay, go back and revisit my Pre-Calculus 1 website and look into elementary row operations if you want to learn how to do this by hand. What you would actually have to do, -4 times row 1, add to row 3, and then you'd want to make a nice 1 out of this somehow, and then use that to knock out whatever's here and whatever's here, and then you will eventually wind up with a nice reduced row echelon form and be able to find the matrices like that. I just use technology. Your calculators probably have something built in where they'll do that as well, so it might be worth learning to do that. Anyway, A is 8, B is -2, C is 6, so that means our f of s is 8 over s plus 3, -2 times s over s squared plus 4, and 3 times 2 over s squared plus 4. And so that means our solution, 8 e to the -3t from this factor, right? 2 times cosine of 2t from this factor, and 3 times sine of 2t from this factor. And there we have it. Now notice, we didn't go through any torment to try to find our constants of integration. The initial condition is built in to the transform system. So maybe it seems like a lot of work, maybe it seems like not a lot of work. Keep in mind, the goal is now we can find transforms for those bizarro type functions, impulse functions, and sawtooth functions, and the like, because as you could see, we were able to find transforms of one of those weird functions like that. So I hope you think that's cool.
Wow.
Yes, it is very cool.